occupied the first bench, then second bench would have been occupied by remaining 4 students. Again 4 students. In this manner, if you call roll number 3, then also 4 students. If you call roll number 4, then also 4 students. And if you call roll number 5, then also 4 students. So each of these 5 students, whom one of whom is called to occupy the first bench, will have 4 options to occupy the second bench. Okay? So total number of way we have got. See, 1 students have 4 options. So 5 students unitary method. 5 into 4, 20 ways. 20 ways. By 20 ways, they occupy 2 bench where repetition not allowed. Repetition means one student will be on will occupy 1 bench only. So this is the basics of permutation. Now to learn permutation, you have to know the term factorial. From the term factor, we have got factorial. Factorial will be denoted by factorial sign or exclamatory sign. This is called exclamatory sign. In words, it is called factorial. Factorial n. If it can be denoted by either factor sign or factorial sign, exclamatory sign. Now, okay. So, suppose from your school, you are from your house, you are going to your school. There is your house, and there is your school. And another example I am referring: bus, by auto, by car, or by taxi. There are 4 vehicles by which you can go from your house to school and return. But one condition is imposed that in the time of going, the vehicle you are choosing will not be allowed to choose in the time of return. That means no repetition not allowed. Means once you choose bus, in the time of return, you will not be allowed to choose bus. So in this way, how many ways you can complete your total up down? See, suppose you are opting bus. Bus means school bus, obviously, to go to for your school. So, according to the condition imposed here, that you will not be allowed to take bus in time of return. So, if you go by bus, how many ways you can return? How many vehicles you will have? 1, 2, 3. You can choose any one out of these 3. So if I go by bus to school, then time of return, I will have 3 vehicles. Yes or no?
Yes, sir.
Now, in this manner, if you go by auto, then also you will have 3 vehicles to come back. If you go by car, then also 3 vehicles. And if you go by taxi, then also 3 vehicles. So each of these 4 vehicles have 3 options to provide you the up and down journey. So total 4 into 12, 4 into 3, 12 ways we can complete one up and down journey. Now, suppose you are going for board form fill up. from your house to your school, you have taken bus, and reaching there, you have seen that you have forgot to bring the registration number. Then
Okay.
you will do what? You will sooner or later you will return back,
Yes, sir.
and again, so already two vehicles are chosen. So again you have to go. So suppose if you choose bus and auto, then you will have only two vehicles to go to your school again. Now you can tell me that arrangement, bus and auto, I could have chosen in how many manners? That already you have got 12 ways. Yes or no?
Yes, sir.
So each of these 12 ways, means bus auto, auto car, car taxi, taxi bus. In this way, with each of these 12 ways, there will have two options to go to your school again. Up, down, up. Okay.
Yes, sir.
So total 12 into 2, 24. And you have gone, and at the end, your last destination, you are coming by one vehicle which is left to your house. So total 4, 3, 2, 1. 24 ways to complete up, down, up, down. Okay? 4, 3,
Okay,
2,
sir.
1. Understand?
Yes, sir.
So these 4 and these preceding 3 factors product, all factors are natural number, is give you factorial. Means this 24 can be written as 4, 3, 2, 1. 4 and these 3 preceding factors product is factorial 4. You denote it by either exclamatory sign or by factor sign. So this is the concept of factorial, which will play the key role in permutation and combination. Okay.
Okay, sir.
So once you get the concept of, say, factorial 4, factorial 4 is 4 into 3 into 2 into 1. So barring this 4, if I club other 3 elements in a bracket, if I put other 3 elements in a bracket, I will get 3 and this 3 preceding consecutive factors. So 4 into factorial 3. That means factorial 4 can be broken into 4 into factorial 3. Now, in the same manner, if I put these thing in a bracket, that 4 into factorial 3 can be broken into 4 into 2 into factorial 2. Okay?
Yes, sir.
So, if that concept is generalized, see factorial n. So, factorial n means n and its preceding n consecutive, natural numbers will be considered as the factor of n. n, n minus 1, n minus 2, n minus 3. In this way, once it will meet, it will terminate where? 5, 3, 4, 3, 2, 1. So, excluding the n, if I wish, I can write n into n minus 1 factorial. That n minus 1 can be broken again into n minus 2 factorial and so on. Okay.
Okay, sir.
Now, you observe that suppose you are told to simplify factorial 2n by factorial n. How to simplify that? Shall I cancel factorial? Shall I cancel n?
No,
No, I will not be
no.
allowed to do that. So I will keep denominator unchanged. Numerator will be, written in terms of factor 2n and its preceding consecutive natural number up to 1. See, I can write 2n, 2n minus 1, 2n minus 2, 2n minus 2n minus 3, 2n minus 4. So the later part will be denoted by dotted line and up to 6, 5, 4, 3, 2, 1. Denominator, that factorial 1 will remain. Now, what we can observe, that this collection of numbers actually is the number of equal number of odd and even factors. Yes or no? Equal number of odd and even factors. Like 1, 2, 3, 4. How many even numbers? 2. How many odd numbers? 2. Yes or no? Similarly, here total 2n factors are there, in which n number of even factors and m number of odd factors are consumed. So you do one thing, you separate them. You separate them and see the outcome. All even numbers are kept separated and all the odd numbers in the same manner will be clubbed in separate manner.
Yes, sir.
And there will be no change in denominator. So what more simplification can be occurred? You see, we have no business with the odd term now, because from the odd term we cannot touch anything common. But from the even term, see, in each even term there is a common factor. See, each even term there is a common factor 2. See, here we have got a 2. Here I can extract 1, 2. Here I can extract 1, 2. See, from these 2 and these factors 2 will give you 2 square. If I take another 2 from here, 2 cube, yes or no? So
Yes, sir.
that even number which is stretched from 2 to 2n, from each even number I can extract 2, and that 2 will get multiplied with themselves and give you 2 to the power n. Okay, it will give you
Okay.
2 to the power n.
And
See, 2 to the power n will be brought out. Once I take 2 to the power n out, what will be left for us? Against it n, against it n minus 1, against it n minus 2, proceeding in this way, 3, 2, 1. So what I will do with these odd terms? Odd terms will have no change. It will remain unchanged, but better if I write it in ascending order. 1, 3, 5 up to 2n. By factorial n. Now, once I get 1 to n numbers product, so instead of the whole thing, I can write factorial n. Instead of the whole thing, I can write factorial n. by factorial n. That part will get cancelled, and this is the simplest version of that expression. Understand? That is the simplest version of the expression using the concept of factorial. Okay.
Okay, sir.
Now, what is permutation exactly? Let us write the basic needs of permutation. See, arranging n elements in R number of rows is same as choosing R elements out of n. Choosing R elements out of n. Suppose there are n numbers like this, n elements.
Okay, sir.
There are n elements like this. And there are R number of rows. So how many ways I can arrange these n elements in R rows? Here n greater than or equal to R. How many ways? Suppose, and see, condition is repetition not allowed. Repetition not allowed means once you choose one element to put it in any row, then that element will not be returned to the bunch. Okay, suppose there are these number of students and there are R benches. You are calling this student to occupy the first bench. That means that student will not return to that bunch of students. Understand? Group of students. Okay.
Okay, sir.
So start in this way. There are n elements. So first row can be built up by anyone out of n elements. Anyone out of n elements by n ways. Why n ways? Why not in one ways? Because suppose I am calling this person to occupy the first row. That means for second row, how many persons still waiting? N minus 1. But
Yes, sir.
who said that this person must come? I could have called this person. I could have called next one. In this way, I could have called anyone out of these n students to occupy the first first row, and that is one way. Yes or no?
Yes, sir.
Just wait. Now, then n minus 1 elements left, and second bench, second row can be occupied or filled up by anyone out of remaining n minus 1 elements by n minus 1 ways. So let us take that example which I had given at the beginning, that there are two benches and 5 students were waiting. So if one student is called up to occupy the first bench, so 4 students are waiting. So with each student there are 4 options. So 5 students, 5 into 4, 20. So I did what? I multiplied 5 into 4. So here you observe, first row, to fill up the first row, n elements were required. To fill up the second row, this is n minus 1 ways. So first two row, in that example I got 5 into 4, here n into n minus 1. Therefore, first two rows can be filled up by, see, with each of these n number, there are n minus 1 arrangement. Suppose I am calling one student, n minus students left to occupy the second bench. So with roll number 1, n minus 1, roll number 2, n minus 1. With each of this roll number 1, there are n minus 1 arrangement. Total arrangement will be in product. The first two rows can be filled up by n into n minus 1 ways. That means here 1, here 1, 2 elements have gone. Okay?
Okay, sir.
And similarly, third row can also be so first three rows. First three rows therefore first three rows can be filled up by n minus 1 n minus 2 ways. So similarly, first 4 rows can be filled up by n, n minus 1, n minus 2, n minus 3 ways. So keep on proceeding the filling and see how many rows are there. Total r number of rows are there. Okay, so
Okay, sir.
you observe first 4 rows is filled up with n up to n minus 3, means ends with 3. Here row was number of rows 4, ends with n minus 3. Had this been 5, it would have been end with n minus 4. Had it been 100, n minus 99. Had it been 1000, n minus 999. Therefore, had this been r, therefore first r rows can be filled up by n, n minus 1, n minus 2, n minus 3 up to n minus c. When 4 rows were concerned, then it was ended with n minus 3, means 3 reduced by 1. So here when r row is concerned, so it will be ended with a term which is reduced by 1 from r, n minus r minus 1. Okay, not n minus r, but n minus r minus 1. Okay,
Okay, sir.
so all the rows are arranged, that means permutation is done, arrangement is done. So permutation or arrangement is completed and it will be denoted by NPR. N, total number of elements. P stands for permutation. And R, chosen element. Chosen element. Chosen element. Okay?
Okay, sir.
But conceptually we have got the definition of permutation, but that is not the working rule. Why? Unless and until you are not able to express the permutation in terms of factorial, then it will not be considered as a standard formula, working rule. Yes or no? It is not working rule. So I have to convert it into working rule. Okay?
Okay, sir.
How to convert? Let's see. We have just got NPR, n, n minus 1, n minus 2, n minus 3 up to n minus r minus 1. That is the total arrangement done, which is called permutation by definition. Now what is working rule? You observe here each term is reduced by 1, and being reduced in this way, it terminated at this step, because once I reach this step, that means all r rows are arranged. So you can ask me, once the total arrangement is done, so how can you simplify it further? Yeah, because this thing terminates here, no point of stretching it. But I have told you, unless and until I am able to convert it into factorial, then it will not be considered as working rule. So see, the number is, each term is reducing, being reduced in this manner. See, n minus 2, next term n minus 3. That means the thing you are subtracting is being increased. Previously you were subtracting 1, then 2. That means number becomes a little bit reduced. Then 3, more reduction. So in this way, you do one thing, you keep on reducing the number. Next number, n minus r. Next number, n minus r plus 1. Because you know the reducing of the numbers is on. Number is being reduced, and reduced in this way, a number when reduced, and reduce up to what extent? It will reduce up to 1. Once it will terminate at 1. So this part which I have written is not at all the part of the problem. Why? Because the total arrangement terminated here. This part is an extra part I had to imposed. That means somehow to get a continuation of reduction of the factors and to reach up to the minimum natural number 1. This part I am borrowing this part. Now to balance, because this part was not in our consideration of arrangement, because arrangement was done here. This part is an extra part I have to introduce, and to balance in denominator also the same has to be bought. So once I am able to do this, what I have got? A continuous product of consecutive factors from 1 to n or n to 1. So that can be written as factorial n. Same will be done in denominator. Factorial n minus 1, n minus r, that is NPR. That is the working rule of permutation, where repetition not allowed. Hope you could follow.
Yes, sir.
Now, from using this basic working rule of board level, can we expect any sum? My answer is yes. Why? We have questions or problems of yesteryears. Let us solve one problem based on this basic board level working rule. What is the sum? 2n plus 1 n minus 1. 2n minus 1 pn. 11 is to 15. No option given. What is the specialty of this sum? It came JEE Main 2023. That means in JEE Main you can expect one sum from basic level permutation also. Few minutes back, we have come to know that NPR factorial n by n minus r factorial. So here we'll use that. See, NPR factorial n by n minus r. Here this n minus 1 will be considered as r. is 2 factorial 2n minus 1 is to 15. So, sorry, mistake of mine. Now, we need simplification. Remove the bracket. That will give you n plus 2 factorial. And proportional means I see ratio proportion, basic concept you know.
Yes, sir.
11 is to 15. Now, revert it. Just reverse. Okay, ratio sign is withdrawn. In next step, I will put this and this together. And this term and this term together. Now, out of this 2n plus 1 and 2n minus 1, which is bigger? Obviously 2n plus 1. So,
Yes.
I can factorize 2n plus 1. Okay, 2n plus 1 and can reduce to this factor. You see, observe 2n plus 2n plus 1, 2n, 2n minus 1 factorial. In denominator also 2n minus 1 factorial. And here n plus 2 is bigger than n minus 1. So I will not bring any change here. I will reduce, I will factorize the denominator part in this case and can diminish the factor to this stage. You see, n plus 2, n, n minus 1 factorial. So what can I cancel? We can cancel from here 2n minus 1 and from here n minus 1. Okay. So gradually we are tending to the final conclusion. So what is left for us? What is left for us? See, 2n plus 1, 2n by n plus 2 into n, that is 11 by 5, 15. Now more simplification is possible. Yes, obviously possible. Clearly visible that n will get cancelled. Yes or no?
Yes, sir.
And we have nothing but to multiply it. How to multiply and simplify? 2 into 2, 4n plus 2 by n plus 2 is equal to 11 by 15. Cross multiply. And in this type of sum, must be careful with your calculation. If any, mistake takes place, then you will get freaked. And here I think there is some mistake of mine. What mistake? Have you observed? After n plus 2, I forgot to write n plus 1. Yes or no?
Yes, sir.
So there is a mistake. So you must be aware of this, that this type of mistake should not take place.
Yes, sir.
So there is just you look at a glance. If there is no other such mistake here, 2n plus 1, n plus 2, 2n minus 1, n minus 1. No mistake. Its difference. Okay. Okay. See. 2n minus 1 factorial, and here n minus 1 factorial. I missed out n plus 1. I missed out n plus 1, n minus 1 factorial. That I missed out. So this part will get cancelled. This part will get cancelled. Now, what conclusion I can draw? That is the big issue. More simplification is possible. 2n plus 1, 2n, and here n, n plus 1, n plus 2 is equal to 11 by 15. Another n I can reduce. This much we can do. Now we have nothing but to open. 4n plus 2 into 15 plus, if you multiply this, n square plus 3n plus 2 into 11. You see, this will give you 60n plus 30 is equal to 11n square, 33n plus 22. 11n square minus 27n minus 8 is equal to 0. Up to this stage we could reach. Now, see what would be the next step of us. Wait for a while. 22. 22. Can it be factorized? I think no. That means not yet factorized. 5. Let's see. You also observe whether there is any mistake of mine. So what ratio is given here? I have written 11 is to 15. Oh, see, just there is a rectification in the question even. It is 21. Okay. Hello. It is 21. 21. This is 11 is to 21. Okay.
Okay, sir.
Wrongly copied. It happens sometimes, human error. It is 21. So you observe the multiplication. see 84n plus 42 is equal to 11n square 33n plus 22. That gives us what? 11n square minus 51n minus 20. Now, if you put 5, you see equation will be solved. N is equal to 5 by middle term factor. Okay. So, this is the basic level, formula that can bring some bonus marks in JEE level. Got it?